Good morning, students. This is Firoz, your new maths mentor. Calculus is originated to solve mainly two geometrical problems. One, finding the tangent to the curve, and the second, the area of the region bounded by the curve. The first was studied by a limit process known as differentiation, and the second we are going to study by another limit process called integration. In first year, we have learned how to find out the derivative of a function. A natural question generally arises if given a function, is there any possibility of arriving a function? If so, is it unique? Such a function, if it actually exists, is called the antiderivative, which leads to the concept of integration. Therefore, integration is the opposite or reversed process of differentiation. So, indefinite integral. Let us suppose d by dx of sin x is equals to cos x. This we knew earlier in the first year. D by dx of a sin x is equals to cos x. Here cos x is the derivative of sin x, and sin x is the antiderivative or primitive of cos x. So d by dx of f of x is equals to f of x. Then integral f of x dx is equals to f of x plus c. So here this f of x is called integrand. This is integrand, and this x is called, f of x is called integrand, and x is the variable of integration, and c is called the constant of integration, and this is arbitrary. So since c is not definite, so that's why we are calling it as indefinite integral. This is indefinite integral. So not only d by dx of sin x is equals to cos x. If I take d by dx of sin x plus 5, it is still cos x. And since the integration is the reversal process of the differentiation, if we integrate, then this is what we are going to get. So integral cos x dx is equals to sin x plus 5. So take another example, d by dx of sin x minus 5, which is a cos x. So integral cos x dx is equals to sin x minus 5. So if you concentrate here, integral cos x dx is equals to sin x here. So if you take integral cos x dx, it is sin x in this situation. If integral cos x dx is equals to sin x plus 5 in this situation, so d by dx of sin x minus 5 is equals to cos x, then integral cos x dx. See, integral cos x dx is sin x minus 5 in this situation. The same integral cos x is sin x plus 5 in this situation, and the same integral cos x dx is equals to sin x here. Therefore, can we reach to a conclusion that d by dx of that integral cos x dx is equals to sin x plus c, because here in this situation c is 0, here c is 5, here c is equals to minus 5. Therefore, this sin x plus c, if we generalize, then this is called the indefinite integral. Already familiar with the areas of the region bounded by the figures like the regular figures like triangle, circle, rectangle, square, etc. So as far as the area of the triangle is concerned, it is obtained by the formula half into base into height. As far as the circle is concerned, it is pi r square, and rectangle L into B, length into breadth, and a square all sides are equal, so x square, so where x is the side. So what if we are asked to find out the area of the region bounded by the curve like this? So we are asked to find out the area of the region bounded by this curve. So which we cannot do it under the regular circumstances. So we need to have some tool to find out the critical curves like this. So maximum, if we join here, then actually rectangle is what we are going to find. But we are unable to find out the area of the region bounded by this critical complex curve. The formulation of integration process is helpful. Therefore, we can arrive to a conclusion that to find out, to evaluate the complex curves like this, so the process of integration is useful. So now, what is a definite integral? So definite integral, let f of x is a continuous function on the closed interval AB, and f of x be an antiderivative of f of x on the open interval AB, that is f dash x. What is f dash x? D by dx of f of x equals to f of x for all x belongs to AB. Then the value fb minus fa is called the definite integral of f on AB. Here there is no constant here, unlike the indefinite integral where we are getting f of x plus c. Here that c is not there. For example, here d by dx of f of x is equals to f of x. So integral f of x dx is equals to f of x plus c. So this is the indefinite integral. Now the range of this is integral a to b f of x dx is equals to f of x plus c a to b. So fb plus c, substitute this b in this, minus f of this a in this, a plus c, then f of b plus c minus f of a, minus into plus minus c gets cancelled, so fb minus fa, so fb minus fa. So this is called the definite integral where c is vanished. So here a is called the lower limit and b is called the upper limit, and this closed interval AB is the range of the integration variable x. Let us discuss some properties of a definite integrals. So properties. So integral a to a f of x dx is equals to 0, because if you take any example, for example, integral sin x dx or integral cos x dx, then this is sin x plus c. So if you apply a comma a, now it is a definite integral, then this a to a has to be written here. Now sin in the place of x, substitute upper limit plus c, minus sin in the place of x, substitute the lower limit a. This time both limits are of the same, plus c. Then sin a minus sin a plus c minus c gets cancelled. So we are left with the 0. Therefore we can arrive to a conclusion that integral a to a f of x dx equals to 0. This is the first property. Second property is integral a to b f of x dx is equals to integral minus integral b to a f of x dx. So whenever the limits are interchanged, then it is differed by a opposite sign. For example, the same if 1 to 2 log x dx if you take, for example, so this is equals to minus 2 to 1 log x dx, because if you take LHS, so integral log x dx is 1 by x. LHS is integral 1 to 2 log x dx. So integral log x dx is 1 by x plus c. So from 1 to 2. So 1 by 2 plus c minus of 1 by 1 minus c. So c gets cancelled. 1 by 2 minus 1 is minus half. Now RHS if you consider, so integral 2 to 1 log x dx is equals to, this is 1 plus x plus c, this time it is 2 to 1, now it is 1 by 1 plus c, so 1 plus c minus of 1 by 2 minus of 1 by 2 plus c, or minus 1 by 2 minus c. C gets cancelled. 1 minus half is plus half. Therefore there is no change in the numerical value. This 1 by 2 and this 1 by 2 remains unchanged, but the problem arises in the sign. So this is minus half, this is plus half. Therefore integral a to b f of x dx equals to minus integral b to a f of x dx. Integral a to b f of x dx is equals to integral a to b f of t dt. Because here, so the value of the definite integral a to b f of x dx is unchanged if we substitute any other variable. So that is why the variable of integration x is called the dummy variable, because so the x can be replaced by any other variable. So that is why if you take integral a to b f of phi of x into phi dash x dx, so phi of x, put phi of x is equals to t, then phi dash x dx is equals to dt. Now change the values of the limits for the new variable which is t. So upper limit t is equals to phi of b, and the lower limit t is equals to phi of a. Therefore here phi of a comma phi of b are the new limits for t having the same range, a b. Therefore integral a to b f of phi of x into phi dash x dx is equals to integral the new limits for the value, the variable t is phi of a, phi of b, so f of phi of x is t into phi dash x dx is dt. Property is for any c belongs to ab, f is integrable on a to c and c to b, then integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx. So here this is a, b, in between c is there, so a to c and c to b. So RHS if I take integral a to c f of x dx plus integral c to b f of x dx, this is equals to integral a to c f of x dx. What is integral f of x dx? F of x plus c from a to c plus here integral f of x dx is f of x, capital F of x plus c, here c to b. That implies f, so simply substitute the upper limit minus lower limit value is definite integral. So fc plus a minus of f of a plus c plus here f of upper limit here is b plus c minus f of lower limit is c plus c. Now this plus c minus c gets cancelled, this plus a here plus c, so this plus c minus c gets cancelled, we are left with fc minus f of a plus fb minus f of c. Minus f of c plus f of c gets cancelled, we are left with fb minus fa. So what is this fb minus fa? Integral a to b f of x dx is what? Capital F of x plus c, substitute upper limit minus lower limit, this is what we are going to get. That means this is integral a to b f of x dx and this is our LHS. Now the integration by parts. So we are already familiar with the integration of by parts in the indefinite integrals. This integration by parts method is useful when the integrand contains the product of two functions. So for example, it may be integral x sin x dx or integral x log of 1 plus x whole square dx, or it may be even useful when the integrand contains only one function. For example, integral log x dx, integral root of a square minus x square dx, integral sine inverse x dx, all are some special types where the second function is treated to be unity. So here the basic question arises as to which function is to be taken first, because as far as x log x dx is concerned, which is first function, either x or log x. So this can be ascertained by the phrase I let. You might have learned all these things in the indefinite integrals. I let: inverse, logarithmic, algebraic, trigonometric and exponential. Inverse is sine inverse x, cos inverse x, tan inverse x, etc. and L is logarithmic function, log x, log of 1 plus x, etc. A is algebraic, so that is x, x square or 1 plus x cube, etc. And that means x power something. Algebraic means trigonometric, sin x, cos x, even hyperbolic functions like sin hx, tan hx, etc. and exponential e power x, a power x. So something to the power of x. Algebraic function is x power something, x, x inverse, x square, etc. Those are algebraic functions. And exponential functions are something to the power of x, e power x, a power x, etc. Okay, so then what is integral f of x into g of x dx that you have learned before? So f of x into integral of g of x dx minus integral of differential quotient of first function, so d by dx of f of x into integral of g of x dx whole dx. So this you have learned in the indefinite integration. Now a to b, if I join here, if I add here, then this is what? This is indefinite integral. This is what? Definite integral. So the definite integral is the ultimate value. So here a to b you apply here and a to b you apply here and find out the value. Then some numerical value is what we are going to get. This is the definite integral when the integration by parts is concerned. Now the fifth property is integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. Now let us take RHS. Integral 0 to a f of a minus x dx. So let us prove this by taking RHS into account. Then we have to show the LHS. So 0 to a f of a minus x dx. This I have considered. Let a minus x equals to t. I am substituting this. This is the x is the variable of integration. So this x we are trying it to change in another variable t. So for this t we need to find out the limits as well, the fresh limits of t also. So a minus x is equals to t. If you differentiate it, minus dx is equals to dt. How it came? So differentiating with respect to x on both sides, then d by dx of a minus x is equals to d by dx of t. So d by dx of a constant is 0 minus d by dx of x is 1 is equals to d by dx of t is dt by dx. That means minus dx is equals to dt or dx is equals to minus dt. So now integral 0 to a f of a minus x dx, let us consider this. Now 0 to a are the limits of the earlier variable integration x. So now the variable of integration is changed in terms of t. Therefore the new variable, the new limits we need to find. So upper limit, so t is equals to a minus x is the upper limit, a 0, lower limit t is equals to a minus the value of x is 0 because this is upper limit and this is lower limit. So 0 if you apply, then this is a. Then 0 to a has been changed in terms of changed into a comma 0, which are the new limits for the variable of integration t. So a to 0 f of a minus x is t we have taken. So into dx is equals to minus dt. This is equals to minus, if I take minus outside, so a to 0 f of t dt. This can be minus, so this is a to 0. A is the lower limit while 0 is the upper limit. If we interchange, then we are getting a minus for this. So minus 0 to a f of t dt. So minus of minus is plus. So integral 0 to a f of t dt. So this integral 0 to a f of t dt can be replaced by integral 0 to a f of x dx. Since t is the dummy variable, so we can change this with any other variable of integration. So here x I have taken. So integral 0 to a f of x dx. What is this? This is LHS. Therefore, integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. Let us discuss the next property. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. As usual, let us consider the RHS. So integral a to b f of a plus b minus x dx is equals to. So this I have considered. I have taken a plus b minus x to be t. I am replacing this with a t. Substitution. So in substitution, bear this thing in your mind that so after finding the dx here, so a to b are the limits of the original variable of integration, which is x, but this x we are trying it to change in t, which is a new variable of integration. Therefore we need to freshly find the limits for the t also. Now d minus dx equals to dt. Therefore dx equals to minus dt. Now upper limit and lower limit. So upper limit t is equals to a plus b minus x. Upper limit is b. So this b gets cancelled, left with a. Lower limit t is equals to a plus b minus x value is a. So a gets cancelled, b. Therefore the limits a to b or no more the limits of a to b, they will be converted into b to a. Therefore integral a to b f of a plus b minus x dx is equals to integral a to b has been changed into b to a. So f of a plus b minus x is t and dx is minus dt. So if we need to avoid this minus, then we need to interchange the limits, because whenever we interchange the limits, they will be differed by a sign. So here a to b ft dt. So what is this ft dt? Can we replace this variable t by x? So f of x dx. See, integral a to b f of x dx is what? Our LHS. Therefore we can take integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. Let us discuss the next property. Integral minus a to a f of x dx is equals to 2 integral 0 to a f of x dx if f of minus x is equals to f of x. What is this? Even function is f of minus x equals to f of x. So, and this is simply is equals to 0 if f of minus x is equals to minus f of x. This is odd function. So, proof minus a to a f of x dx is equals to, see this number line for example. So this is minus a and this is plus a and 0 is in between. Therefore, we can split the interval from minus a to 0 and 0 to a. So minus a to 0 f of x dx plus 0 to a f of x dx. So let us consider this. Let x is equals to minus t, then dx is equals to minus dt. Now change the limits. Upper limit is equals to t is equals to minus x, so minus 0, so 0. Lower limit t is equals to minus x, minus of minus, so plus a. So this is equals to, I am only considering this, I am not changing this. So minus a to 0 can be a to 0 now into f of x is minus t, f of x is minus t, dx is minus dt plus 0 to a f of x dx. This is equals to minus a to 0 f of minus t, this minus dt, minus I have written outside, plus 0 to a f of x dx. Now if we cancel this minus, then we need to, sorry, this is plus a. Okay, so we need to interchange. That means 0 to a f of minus t dt plus 0 to a f of x dx. Then this is equals to 0 to a this f of minus t dt. So since t is a dummy variable, t can be replaced with even x also. So f of minus x dx plus integral 0 to a f of x dx. That means integral 0 to a f of x plus f of minus x dx. So now if f of minus x is plus f of x, then 0 to a f of x plus f of x, 2 integral 0 to a f of x dx. And if f of minus x is equals to minus f of x, this plus of f of x minus f of x gets cancelled, so we left with a 0. Next property is integral 0 to 2a f of x dx is equals to 2 integral 0 to a f of x dx if f of 2a minus x is equals to f of x, and the same value is equals to 0 if f of 2a minus x is equals to minus f of x. So to prove this, I am taking LHS 0 to 2a f of x dx is equals to this number line. So this is 0 and this is 2a, so this is a. So until a we can split the interval 0 to 2a. So 0 to a and a to 2a. So this is 0 to a f of x dx plus a to 2a f of x dx. So let 2a minus x is equals to t I am replacing with. So that means minus dx equals to dt. Therefore dx is equals to minus dt. Okay, and so we need to change the limits also, upper limit. So t is equals to 2a minus 2a, because in the value of x upper limit is 2a. 2a minus 2a is 0, and lower limit t is equals to 2a minus a, that is a. Therefore integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus a to 2a is changed into a to 0 f of. So here 2a minus x equals to t. I want x. So if this minus x, if you transpose here, and t if you bring here, so 2a minus t is x. So x value can be replaced as 2a minus t. So dx value is minus dt, that is equals to 0 to a f of x dx. So plus into minus, minus a to 0 f of 2a minus t dt. Now this is 0 to a f of x dx. So if you interchange these two values, upper limits and lower limits, then actually this minus will be plus, because whenever we interchange the limits, then the value is differed by an opposite sign. So this is 0 to a f of 2a minus t dt, and we can even replace this t with x. Then now 0 to a f of x dx. Now if f of 2a minus x is equals to plus f of x, then what will happen? This is 0 to a f of x dx plus this is also f of x, integral 0 to a f of x dx, that is equals to 2 integral 0 to a f of x dx. And if 2a minus x is equals to minus f of x, then in this, in 0 to a f of x dx, 2a minus f of 2a minus x is minus f of x. This integral 0 to a f of x dx minus integral 0 to f of x dx gets cancelled, and we left with a 0. So this is equals to 0 if f of 2a minus x is equals to minus f of x. Let us write all the properties that we have learned at one place for the better understanding, and if we write all the properties here, then it is easy for us to work out the problems from tomorrow onwards. So very first is integral a to a f of x dx equals to 0, integral a to b f of x dx is equals to integral minus b to a f of x dx, integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx, where c is lying in between a and b, or c is Next, integral b. So c is lying in between a and b. Next, integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. Next, integral a to b f of x dx is equals to integral a to b f of t dt. Integral a to b f of x into g of x dx is equals to f of x into integral g of x dx from a to b minus integral of from a to b d by dx of f of x into integral g of x dx whole dx. Integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. Integral 0 to a f of x dx is equals to 2 integral 0 to a f of x dx if f of minus x is equals to f of x even function and is equals to 0 if f of minus x is equals to minus f of x which is odd. Ninth one, 0 to 2a f of x dx is equals to 2 integral 0 to a f of x dx if f of 2a minus x is equals to f of x. This is equals to 0 if f of 2a minus x is equals to minus f of x. So with the help of this we can write another one also. Integral 0 to a f of x dx is equals to 2 integral 0 to a by 2 f of x dx if f of a minus x is equals to f of x, and this is equals to 0 if f of a minus x is equals to minus f of x, because here 0 to 2a 2 will come forward and half of this 2a is a when f of upper limit minus x is equals to f of x. Here 0 to a 2 will come forward as usual like this and a's half, here 2a's half is a, here a's half is a by 2 f of x dx if upper limit minus x, here also 2a minus x f of x, here a minus x is f of a minus x is equals to f of x.